For 5, we get to do absolute value inequalities. So here's what you need to know. If it is a less than sign, it's saying that the distance between x and 0 is going to be less than that number. These are going to graph to be and inequalities, okay? So you're going to want to have that written down somewhere. Less than sign means and. Later, we're going to go over the fact that a greater than sign means or, okay? So for these, you're going to have to kind of mix your inequality rules with your solving absolute value rules. Remember, with an absolute value equation, if this was an equal sign, what I would have said to do is n minus 8 equals 2, and n minus 8 equals negative 2. And the reason you were able to do that, or the reason you did that, was because we recognized the fact that this over here could have been a positive or a negative number. We weren't sure. So really what I was saying was this could have been a positive 2 or a negative 2 that was equaling this 2. Really what we were doing was changing the positive negative sign on the left and moving it to the right, which wasn't really an issue to think about when we were doing it with equations. But the reason I'm pointing this out now is really what I've done is I've said I have n minus 8 as a positive answer equaling 2 and n minus 8 as a negative number equaling 2. Except they weren't equal signs either, were they? They were less than signs. And to get this negative sign to the other side, I'm dividing by negative 1, so that I have n minus 8, divided by a negative, so that means I switch the sign to be negative 2. Mathematically, that's what we're doing. If you'd like a shortcut, here's the bottom line. Here's what you need to know. Take this bad boy up here, write it down twice, without the absolute value bars, and on the second one, I need you to switch the sign so it's facing the other way and make it a negative 2. Okay, bottom line, that's what you need to know. And then solve. Good news is these are usually going to be not too bad as far as the solving goes. Just adding 8 each time. And now I can plot that. So I have 6 and 10. Extra ink. So this one does get to be a nice happy dot. And is bigger than it. And 10 is a dot. And is less than. The cool thing with absolute values is that they will always graph to be your, like, quote, classic and and ors. I call a classic and to be where it's shaded in the middle, and a classic or to be where it's shaded on the outside. Those are kind of your classic values. So the next one, I see that it's a less than sign, so this means it's going to be an and, which means it should shade in the middle. Oops, I wanted to leave that there. So let's go ahead and do this. It would be 2c minus 5 is less than negative 3. And then the other one should be 2c minus 5, switch the sign, and then make it negative. Whoa, hold on a second. It was already negative. Do you remember when we did equations, I said if it's already negative, you need to stop and ask yourself some questions? Let's stop and ask ourselves, what's really going on here? Here I have absolute value bars. Absolute value bars are always going to give me a positive number. And then negative 3. You're telling me a positive number is always going to be less than negative 3. Well, that's just simply not true. So this one's answer is no solution. Let's say you didn't recognize that at the beginning. You eventually would have figured it out. So let me, 2c minus 5 greater than negative 3. Let me just kind of solve this really quick, and I'll show you what I mean. 2c is less than... Oops, that's supposed to be a C. So C is less than 1. Oh, I feel like I forgot to make it positive, that's why. Okay, so then it should be 8. Okay, I know I did that quickly. But you would have gotten to here where it says C is less than 1 and C is greater than 4. And because it's an and inequality, because of this symbol right here, that's how I know that it would have been no solution, because nothing graphs over here. Okay? All right, so with an greater than sign, that means it's going to be an or inequality. So I see that. That means this one's going to be a nice happy or. And you do the exact same thing. 2k plus 1 is greater than 7, and on the second equation, it's going to be 2k plus 1 is less than a negative 7. I'm going to solve each of these. Oops. Alright, I'm kind of running out of room on my graph here because I wrote in my way. And was that a 3? Okay, so circle, and k is less than, and circle, and k is greater than. And because it's an or, and I promised you they will graph like classic ors, should graph like that. If I look at 3b, I go to start it here, and I get to about this point, and I realize that, hold up, it was already negative. So let's read that. A positive number is bigger than a negative 5. Is that true? Yeah. Positive numbers are bigger than negative numbers. So this one is all reals. And again, if you had graphed, or if you'd gone ahead and actually solved this, because you forgot to kind of double check there, 1, 11, you would have found the same answer. Okay, that's all for this one.